Okay, a very good afternoon to all of you. I'm going to present a paper on the topic design of diagonally slotted microstrip patch antenna for wireless application. I am my co-authors are Dr. Vibha Kumar Sachan, Mr. Saptarishi Gupta, and Dr. Satyasai Shrikant. So some few slides for introductory part. Actually, this is the microstrip patch antenna. What is that? I am going to explain that. That consists of a radiating patch on one side of a dielectric substrate, which has a ground plane on the other side. Now, the patch is generally it is made of conducting materials such as copper or gold, and it can take any possible shape. As such, in this slide, I am showing the rectangular shape. It can be square, it can be ring, it can be any shape. So the radiating patch and the feed lines, they are usually photo etched on the dielectric substrate. So why we are choosing this strip antennas? They have very beautiful advantages. As such, they have low profile structure. They are easy to fabricate. They are easy to feed, and they are easy to incorporate with other microstrip circuits elements and integrate into system. The patterns are somewhat hemispherical with a moderate directivity. Easy to use in an array to increase the directivity of the antenna. Now, just to calculate the, if I'm going to explain my topic on the square patch. So, if you are, I have, if I want to calculate the length and width of the patch antenna. So, these are the some design equations to calculate W and L of the patch. We have to just specify the epsilon R for the material, for which frequency you are going to calculate, and what is the thickness of the dielectric substrate. So we can first specify these parameter, and using these parameter with this equation, we can calculate the width of the patch antenna. From that, we can calculate the epsilon effective. These are the equation which we have written from the book Balanis. And once we have calculated the W, the width of the patch, we can calculate the extension of the length, that is del L by H. These are some equation. Now just to calculate the actual length, that is L plus 1 by 2 epsilon R. Epsilon R, FR is the resonating frequency on which on that frequency my antenna will radiate. And epsilon R effective I have already calculated in the last equation. Then mu naught epsilon naught minus 2 del L. By these equation, I can calculate the length and width of my patch antenna. Now, I'm coming over to my research work. This is my design. By designing of microstrip antenna, I have designed my antenna for the L band. So this in this paper, I am designing my antenna to achieve the circular polarization. So I have designed using i3D software, electromagnetic simulator. I have chosen four geometries over the patch, that is squares. We have cut the slots in the form of squares, circles, rings, and crosses I have chosen. From these design I have simulated on the i3D simulator, and I have found out some responses which are showing the circular polarization. The parameters like axial ratio performance plot, reflection plot, impedance plot, I have studied. So by the axial ratio parameter, I can prove that my antenna is radiating in the circular manner. So we will say this is the circular polarization. For circular polarization, axial ratio is the very important parameter. Means the gain, it should be the, what is the axial ratio? It is the ratio of the major axis and the minor axis, which should be 1. Or if you calculate in dB, it should be 0 dB. So in my paper, I have calculated the dB in it is near approx 4 dB. So we maximally somehow it is showing the circular polarization. And VSWR I will show you. What is VSWR? VSWR means voltage standing wave ratio. If the ratio is very larger, we will say our antenna is not radiating effectively. If the ratio is 1/1, so we can say my antenna is radiating in a very effective manner. Means all the transmitted energies is transferred into the space. So this is the first design. This is the first design. Here these are the specification on the patch antenna. These are the width and length which I have shown you. We can calculate with that equations. So on the patch we have calculated diagonally 2 square slots. These are the specifications of the slots. This is the loss tangent del 0.024, and I have simulated this antenna on the glass epoxy type substrate. So the dielectric constant for that is 4.2. The feeding distance for this type of patch in this 15 millimeter, and area dimension is 100 cross 100 millimeter for the patch length and width. Dielectric layer height, this is the height h, this is 1.6 millimeter, and the patch dimensions are 78 millimeter cross 78 millimeter, and the frequency at which we have simulated, that is 1.2, means FR is 1.28 gigahertz. So in this design you can see here I have cut 2 square slots diagonally. This is my design 1. Now, and again, in the another design, I have chosen the crossed slot. Diagonally, I have chosen the crosser. That dimensions I will show you in the next slide. Cross plus slotted diagonally in the microstrip patch antenna. And this is the design number 3, in which I have chosen the annular rings slots. The diameters, the upper ring diameter is 7.5 millimeter and the inner ring diameter is 6.5 millimeter. Now in the design 4, I have chosen only the circular slot diagonally. So by designing all these 4 design, I have simulated all the 4 design, and I have plotted the axial ratio using the i3D simulator. I got the axial ratio for the antenna 1, that is near about 0 to 4 dB. So it is showing some of the circular polarization for antenna number 2. Again, it is showing near about frequency 2.5 to 3, 4 dB. This is the axial ratio plot the antenna number 3, and this is the axial ratio plot the antenna number 4. Here I have mentioned the antenna number 4, antenna number 3, antenna number 4. For these all designs, we have plotted the axial ratio plot, which is showing the circular polarization. Now the for very first antenna which I have shown you here, this circular patch, this is square slots which I have designed that diagonally, this particular antenna I have fabricated also. I can show here this is design. So we have done the we have compared the simulated results and fabricated results both. This is the table for that. We have calculated the gain for the simulated antenna, that is 4.19. For the fabricated antenna, this is the antenna. Here I am showing you the gain is 4.08. The return loss is minus 17 dB, minus 17.1. Axial ratio 11.4%. For fabricated, it is showing some showing some tolerances with 2% error, that is 10.6, and VSWR is 1.26 for simulated, and fabricated result 1.31. So this is my I have done fabrication only for the antenna design number 1, where we have cut the 2 slots, square slots diagonally. And this is the return loss for that antenna, which I am showing here in the table, that is minus 17 point. This is the simulated result. Now conclusion is what I have simulated 4 designs and fabricated antenna number 1, and I have I'm showing you the simulated result, comparing the simulated result and fabricated result for the square slots. So this is the this is showing the circular polarization in L band. So, and I have my future scope is this. I am trying to design the antenna for which will show the circular polarization in the S and C band for further process. And this is the future scope. Future studies are still in progress. I will try to design the antenna for the same antenna in the C band by doing some modifications in the design, or by choosing some other material, meta material, whatever. And so this is the future scope for this, which will be suitable for the mobile and wireless communication application. And these are the references which I from which we have taken the literature survey. Thank you.
Thank you, ma'am. That was a wonderful presentation. If any queries are there, I would request all the participants to put it in the chat box. And ma'am, I would request you to please share your email ID on the chat box, so that if other participants would like to contact you with any queries or about discuss about your paper, they can email to you officially. So I request all the participants, once your paper presentation is completed, please post your email ID in the chat box, so that any queries or interaction with the other participants, well, since all are doing research, you might need each other's help in a few cases. So I request all of you to please post your email ID in the chat box. Thank you, ma'am. And any queries
Thank
are
you, sir.
there, please put it in the chat box. So go ahead.
All right, thank you very much for moving my presentation ahead. And good afternoon, everyone. My name is Muhammad Mustafa, and I will present our work with my co-author Karim Mahfouz about the selection of best sites for aquifer storage and recovery in the Eastern District of Abu Dhabi. So this is the outline of the presentation. Introduction, we'll talk about the ASR, aquifer storage and recovery, the study area, the site selection, results and discussions, and then conclusions and references. In Abu Dhabi, we depend mainly on groundwater and desalinated water. We desalinate water for the use of domestic use, but sometimes we have more water desalinated. So we propose here to inject this water into groundwater for a strategic storage to be used in the future. So we have desalination plants. The total water consumed in the Emirate is 29% from desalination plants, and this figure shows the desalination capacity with time, and as you can see, it's increasing with time. So because we have a shortage in water, we thought about storing this additional desalinated water in groundwater to be used in the future. So ASR, or aquifer storage and recovery, is basically injecting excess water through wells or other means into the groundwater, and then when needed, we can recover it or pump it out again in the future. And it has been developed in the States since 1968 and has been applied in UAE recently in the last few decades. So we inject water and then we recover it later on. The study area is in the eastern part of Abu Dhabi, near Al Ain city, and this is the study area in Al Ain region, which is in the eastern region of the Emirate of Abu Dhabi. So Al Ain is the second largest city in the Emirate of Abu Dhabi. It has 0.76 million population. And before we select the sites, we had a criteria that we developed to select the best sites, and we gave a score for each site. So these are the sites that we tested and the scores. And out of these sites, we selected 2 sites with high scores, Al Shuaib and Al Kharir, which are in the eastern part of Abu Dhabi, and which has the higher scores and also the best location. So we used the mod flow to model the groundwater in these 2 sites and check if they are suitable for aquifer storage and recovery in this area. And we used the software to develop the model for these 2 areas. So we had to prepare the data. So we prepared all the data required for the model, including geological and hydrogeological data from old reports and old publications. And this is the model developed with the boundary conditions for the model study area. And as you can see here, this is a screenshot from the software after we developed the model. We did the model calibration using some existing data from several wells throughout the emirate. And we can see here that there's a good agreement between the modeled numbers and the field numbers that we get from the field. And then after we calibrated the model, it was ready for to be used with the two sites that we selected. So we modeled the first site, Al Kharir, and these are the results from the first site. These are the water level or the water head at different times for the first site. We did five simulations, 5 scenarios. And these are the results for the 5 scenarios that we developed for the first site. And these are the results for the same 5 scenarios, but for the second site, Al Shuaib, at different times from 2015 until 2030. And then we compared between the two sites to check which site is the best for future aquifer storage and recovery. So we compared the water heads to make sure that we don't have any excess water built up in the aquifer and make sure that we can recover this water in the future. So we compared between the two sites. And based on this comparison, we found out that these are the 5 scenarios we had. And we found out that for Al Kharir site, the first 3 scenarios are applicable until 2030. And the 2 last scenarios, 4 and 5, are applicable only until 2020. For Al Shuaib site, the first 2 scenarios are applicable until 2030. The third scenario is applicable until 2020, and the last 2 scenarios for 4 and 5 are applicable until 2015. Results and discussion. So at the end we were able to simulate the groundwater flow in 2 sites, and we were able to make sure that Al Shuaib sites and Al Kharir are good sites for aquifer storage and recovery. And then we selected the best sites. And these are our conclusions for the best sites and for the different scenarios we presented. If you have any questions, please let me know. Thank you.
Instructional model using content and language integrated learning to enhance English for specific content of undergraduate students in Thailand. Yeah. The COVID-19 situation has impact on teaching and learning methods around the world, especially in Thailand, where many teachers, school administrators, and the Ministry of Education have not prepared. Online instructional model is one of the major issues for education process during the unexpected epidemic. This forces teachers and learning using technology to work and study from home. This study aims to synthesize a new safety education instructional model using content and language integrated learning or CLIU through social media to enhance digital well-being and the ability of using English vocabulary for health and physical education undergraduate students. English for specific content, ESC. This study defines English for specific content. ESC apply the concept of English for specific purpose. ESP is an important section of English language education. ESP aims to scope to deliver the specific needs English language learner. Instructional model development. Instructional model development process is to provide conceptual and communication tools that can be used to visualize, direct, and manage processes as a guide learning. The study reviews many lists of IMD to find the suitable steps to produce a new instructional model for learners. Content and language integrated learning. Content and language integrated learning, or CLIL, is an approach that students learn a subject and a second language at the same time. A health education course, for example, can be taught to students in teaching, and they will not only learn about health, but also obtain relevant vocabulary and language skills. Social media. Social media has become a key instrument for learning activities. Social media means pathways of connecting among people in which they generate, share, and exchange information and ideas in social and network. Research methodology. The research keeping research method is one of the well-known qualitative types of research, using systematic reviews, analysis, and synthesis from 40 research articles, 15 textbooks related to instructional model development, CLIL approach, social media, and English for specific content. These criteria for employing documents are credibility, representativeness, and meaning. Conclusion. This finding recommends that this instructional model composed of 4 components. The first, objective in digital well-being, and ESC focusing on vocabulary relating to health education. Second, content of e-safety, which including health aspect in e-safety knowledge, the risk of releasing personal information, cyber victimization, digital literacy, and wellness. The third, learning process applying CLIL, which concerning on forces and social media, which focusing on social media review and discussion network. The fourth, evaluation based on well-being and ESC vocabularies on e-safety content. The new e-safety education instructional model using content and language integrated learning through social media to enhance digital well-being and the ability of using English vocabulary for undergraduate students. Thank you.
Thank you, ma'am. That was a wonderful presentation.
Afternoon, everyone. My name is Vacharapong Narijan. Today, I would like to present about photoelectrocatalytic solar cell prototype development for organic dye degradation. The presentation is divided into 5 topics. The first one is introduction. The second is objective. The third methodology. The fourth liaison discussion, and the last one is conclusion. Now let's begin with introduction. The statement of the problem: in the future, dye may be an important parameter for dye wastewater treatment. Due to at the present, many textile industry use a lot of water for manufacturing process. Moreover, the technology in manufacturing can use dye for dyeing on printed fabric at frequency. So if dye come out while washing or dyeing the textile material. Furthermore, it resulted in water pollution that contain a variety of chemical and toxic. And next, there are many methods for dye wastewater treatment, such as ultrafiltration. The advantage of this method is a membrane can be resistant to acid and base chemical. The next one is sedimentation. The advantage of this method is sedimentation itself. However, disadvantage of two methods is unable to transform any toxic organic pollutants into the non-hazardous compound. Another method is photocatalysis. The advantage of this method is able to disperse the wastewater, but slow frequency from the combination effect and difficult to remove photocatalysis from the system. And it is required to use technique. It is found that photoelectrocatalytic technique is an interesting technique to be applied for dye wastewater treatment because of low cost, high frequency, and eco-friendly. So photoelectrocatalytic technique is chosen for dye wastewater treatment. Let's know about the principle of photoelectrocatalytic. When the semiconductor is activated by visible light, electron will move from valence band to conduction band. It causes hole at the valence band that can oxidize water into hydroxyl radical. And then hydroxyl radical dispersed from electrode surface, oxidized organic convert to carbon dioxide and water. And electron at the conduction band will be conducted to electrode by applying positive potential. And then electron will flow from anode electrode to cathode electrode to reduce water into hydrogen. The photoelectrocatalytic technique is a semiconductor deposition on the electrode. So there must be some means to choose the semiconductor. And next, there are lots of semiconductors, such as titanium dioxide, zinc oxide, tungsten oxide, and bismuth radiate. But in this research, the researchers chosen tungsten oxide and bismuth radiate as a semiconductor because of high positive potentials and narrow bandgap energy. They can respond to visible light which has in the nature. And next, a tungsten oxide were used to combine bismuth radiate for help to reduce recombination effect. When the semiconductor is activated by visible light, electron will move from valence band to conduction band of the both semiconductor. The electron at the conduction band of bismuth radiate layer was transferred to conduction band of tungsten oxide layer. And then the electron at the conduction band will be conducted to electrode by applying positive potential, which helps to reduce recombination effects of electron and hole. At the same time, the hole generates at the valence band position of the both semiconductor was separated and transferred from valence band of tungsten oxide layer to valence band of bismuth radiate layer. It causes many holes at the surface. So the many holes at the surface that can oxidize water into hydroxyl radical. And then hydroxyl radical oxidize organic convert to carbon dioxide and water. And next. It is a preparation technique of tungsten oxide bismuth radiate thin film, which has a lot of methods such as spin coating technique. The advantage of this method is it can control the thickness of the film, but difficult to scaling up. The next one is spray pyrolysis technique. The advantage of this method is able to scaling up and it can control the thickness of the film, but complicates method and high cost. And next one is technique that interests the researcher. Is it deep coating technique? Because it's simple method, low cost, and able to scaling up. So deep coating technique is suitable to deposit the electrode. And next, objective of this research. First, to develop the tungsten oxide bismuth radiate photoanode preparations by simple deep coating method. Second, to develop the photoelectrocatalytic cell prototype combining with solar cell for dye waste water treatment. And the last one is to design and develop a large-scale photoelectrocatalytic prototype for dye waste water treatment. And next, methodology. Methodology are divided into three parts. The first part is preparations of anode electrode. The second part is design the photoelectrocatalytic reactor combined solar cell. And the last one is design of large-scale photoelectrocatalytic prototype cell. The first part is about preparations of anode electrode. This slide shows the developments of the precursor solution preparation. First of all, preparation bismuth radiate solution. Initially, bismuth nitrate pentahydrate was dissolved in the acetic acid, and vanadium acetylcetonate was dissolved in the acetylacetone. And then the solution was mixed as ester. We will get bismuth radiate solution. And tungsten oxide solution was dissolved in the tungsten acid in the 30% ammonium hydroxide. And then refract at the 60 degrees Celsius for 1 hour. We will get tungsten oxide solution for using. And then the FTO substrate was dipped into the 0.1 molar tungsten oxide in the first layer and die at 150 degrees Celsius for 5 minutes. After that, FTO tungsten oxide was dipped into the 0.1 molar bismuth radiate in the second layer and die again. And finally, FTO tungsten oxide bismuth radiate was calcination temperature at the 550 degrees Celsius for 1 hour. We will get FTO tungsten oxide bismuth radiate for using. And next, study characterization of electrode surface. You can see parameter study from this slide. And next, liaison discussion. This slide shows the UV visible adsorption spectra of FTO substrate, FTO tungsten oxide, and FTO tungsten oxide bitmut varieties prepared by dip coating technique and spin coating technique. From the figure, show the higher visible light adsorption intensity of tungsten oxide bitmut varieties by dip coating technique, then the spin coating technique, due to the effects of thin film coverage on the substrate. And the figure A shows the correlation between the adsorbent coefficient and band gap energy, which could be calculated at the 2.4 and 2.8 electron volt, corresponding with the bitmut varieties and tungsten oxide respectively. And next, this slide shows the top view morphology of tungsten oxide bitmut variety thin film analysis by AFM and SEM technique with small particle size of 100 to 200 nanometer. And you can see high surface roughness on the substrate. And next, XPS analysis confirm the chemical composition and oxidation state of elements on the FTO tungsten oxide bitmut varieties prepared by dip coating technique very well. From the figure, we can confirm that the bitmut T plus and vanadium 5 plus in the bitmut variety and tungsten 6 plus at the tungsten oxide, and still have oxygen in the crystalline structure of tungsten oxide and bitmut variety. And next, XRD pattern. From the figure, we can confirm that the monoclinic bitmut varieties and monoclinic tungsten oxide when calcination temperature at the 550 degrees Celsius. Such study can confirm that tungsten oxide bitmut varieties semiconductor are actually on the electrode and have a crystalline structure suitable for use as a photocatalytic semiconductor on the electrode for oxidation activity. And next, figure 5 shows the photocurrents from the water oxidation process using the tungsten oxide bitmut varieties electrode prepared by developed dip coating technique was significantly higher than spin coating technique. And moreover, dip coating technique is simple method, low cost, and able to scaling up, is suitable for application to large scale. And next, the second part is design the photoelectrocatalytic reactor combined solar cell. This slide shows the design photoelectrocatalytic cell prototype for organic dye.
Excuse me, sir, a gentle reminder, 8 minutes are given to all the participants, and since there are 33 papers, so kindly wrap it up faster.
Okay. Okay. In the system consists of FTO tungsten oxide bitmut varieties as a photoanode and stainless steel at the cathode electrode, analyze radiation and apply potentials by solar cell. Next, this slide shows the percentile degradations of methylene blue and lonamine B. The results show that the developments of the photoelectrocatalytic cell can remove methylene blue up to 94% and lonamine B up to 93% in 3 hours. And moreover, still reduce the COD value up to 82% in 3 hours. Okay, the last part is design of large-scale photoelectrocatalytic prototype cell. And this slide design and develop photoelectrocatalytic cell. Okay, this slide shows the percentile degradations of orange-less color. The results show that the photoelectrocatalytic cell can remove orange-less color 100% in 5 minutes. And moreover, P cell can remove nitrite 100% in 50 minutes. And the system can also simultaneously produce oxygen gas by removing nitrites and organic matter. And next, conclusion. The developments of the FTO tungsten oxide bitmut varieties electrode using the dip coating method show a higher visible light absorption and better morphology property causes photoelectrocatalytic activity improvement. The developed photoelectrocatalytic cell prototype combining with solar cell for using FTO tungsten oxide bitmut varieties photoanode presents high efficiency 94% of methylene blue and 93% of lonamine B. and can reduce COD value up to 82% in 3 hours. And the design of large-scale photoelectrocatalytic prototype cell could eliminate 100% of the organic dye within 5 minutes. This work demonstrates a high efficiency of photoelectrocatalytic reactor with a sample and offer an energy-saving process suitable for future applications for dye wastewater treatment system on the large scale. Thank you for your attention.
Thank you, sir. That was a wonderful presentation.
Construction projects in Mpumalanga in South Africa. And my presentation is taking that form where I'm looking at the introduction, the aims of the objectives and objectives of the study, the literature review, the methodology, and the findings and discussions, as well as the conclusions. So by way of introduction, you know, it's been, although the construction industry is regarded as a major contributor and an integral component of the development of economies, particularly in the developing countries, there are many construction projects that are experiencing delays, especially in the province, and that exceed the initial due date performance. So many of these construction projects, they suffer poor design, inconsistency due to date performance and cost management. And this has led to the rethinking of the industry's performance and how it could be improved. So the aim of the study was to identify the factors impacting the performance of rural-based construction projects and to recommend ways to make projects successful in rural areas in the South African province of Mpumalanga. The sub-objectives was to identify the factors and risks that cause the failure of rural construction projects. And number two, to identify the skill sets required for the execution of those construction projects. And number three, to recommend ways to mitigate challenges in rural construction projects. So from the literature review, there's some critical factors that were found from the literature around the world that impacted upon the execution of construction projects. Factors such as poor communication, inexperienced project managers, scope changes from the owner during the course of the project, sometimes poor planning and inadequate planning. Sometimes the projects faced contractors' financial problems, and sometimes other factors cited by LIM 2021 is poor site management and supervision, underestimation of project costs, incompetent resource allocation, also project structures, and then insufficient resources, accessibility in terms of money, work, plant, and material for top supervision and sponsors and the like. Now, the method which was adopted to investigate these factors that affect the performance of rural projects was a quantitative approach in the province. And a questionnaire was fielded and to about 100 respondents, and all of the respondents managed to give back the questionnaires, and all the questionnaires were reusable. So the findings in terms of the factors that cause failure were ranked, and these were as follows: inexperience, scope creep, improper planning and scheduling, poor risk management during the course of the project, productive issues and delays in terms of supply of materials, interference of the client in the construction process, inadequate human technology and resources, poor leadership on the part of the project itself, poor communication skills, financial challenges, and issue of changing budgets and inaccurate estimation at the beginning of the project, and also the issue of the team not working together and the incompetence of the workers. And in conclusion, the findings showed that the factors impacting the rural projects included issues like have been alluded in the first in the previous slide. Lack of experience, change of scope, improper planning and scheduling, inadequate documentation and tracking, poor risk issues with productivity delays, and customer interference in the construction industry. Sometimes there were insufficient human and technological resources, poor leadership in terms of finance budgeting, and as a result, the recommendations from the study are that the project should recruit qualified project managers who are trained with the necessary expertise and skills, and then the project managers should be able to design, plan, execute the project, and monitor in terms of budget, plan in terms of resources, and monitor in terms of the finance in real time as the project is being executed. And the team members or the employees should be trained and educated to manage issues like risk and any eventualities that rise during the course of the project. So that is the research, and thank you very much.
My research is focused on different factors affecting vibration damping properties of different polymer materials. In general, mechanical vibrations are undesirable in many cases, for example, in means of transport, home appliances, and manufacturing processes. The vibrations can have a negative effect on manufacturing quality and productivity, work safety, etc. Furthermore, vibration can be a source of unwanted noise. For these reasons, it's necessary to reduce mechanical vibration. In general, there are different possibilities of this elimination. I thought that the paper is focused on study of vibration damping properties of different polymer materials. The vibration damping properties were investigated by means of a forced oscillation method. We've compared basic and special polymer materials. Here in this figure.
Sir, your slides are not changing. It's on the first page itself.
Pardon?
Your slides are not changing. It's just, you're still, it's showing in the first slide itself. It's displaying first slide.
Only first?
Yes, sir. You can click on to the second, third as
I
per
tried
the
it.
row. So
Only first.
You click on to the second slide, sir, if possible. Now it's changing. So once you change your slide, please click on the respective slides so that it keeps changing.
New share.
Please go ahead. Continue, sir.
It's okay now? Or?
Yes, sir. Now it's in introduction.
Yes. You see the second slide now. Okay. So I thought that mechanical vibration are undesirable in many cases. It's necessary to reduce the mechanical vibration. So in this table, we studied firstly the basic polymer materials. So, for example, polyurethane foams, recycled polyurethane foams, and very high density polymer material, for example, polypropylene, polyvinyl chloride, etc. Furthermore, we studied rubber composites with with different compositions. Firstly, we have a rubber composite fillet with different concentrations of dimethyl sulfone. It's from 0 to 16.2. We have different rubber samples with different concentrations. And secondly, we studied different rubber composites that were filled with different concentrations of stearin. The stearin was a modifier in these composites. I thought that the mechanical vibrations were investigated by means of the force oscillations method. So the measuring equipment consists of the multi-analyzer, power amplifier, and the vibration mini shaker. Here we have the force oscillations in this frequency range from 2 to 3200 Hertz. And on top of the sample, we have some inertial mass. Here we can see the measuring equipment on this figure. Really, for example, the shaker with the sample. Here in this figure, it's shown the principle of the force oscillations method. In general, the materials are characterized by some material stiffness and damping coefficient. So we have here these forces, and based on the forces, we can determine the vibration transmissibility. So it's given by the ratio of displacement amplitudes that were measured on input and output sides of the tested sample. So for this reason, in general, we can have 3 different types of mechanical vibration: resonance, undamped, and damped vibrations. Because we have a harmonically excited vibration, we can express the vibration transmissibility by the acceleration ratio too. And here we can express the vibration transmissibility based on the acting forces, as was seen on the previous figure. And if we have this condition, from this condition, we can determine local extrema for determination of the first resonance frequency. So this is this equation. And it's evident that if the damping ratio is increasing, it has a positive effect on decreasing the first resonance frequency. In general, if the first resonance frequency is smaller, the materials are characterized by better vibration damping properties. Now to results. Firstly, we've compared the different material types on vibration damping properties. In this figure, we can see the materials of high density. So here on the top, this point is proportional to the first resonant frequency. I thought that better is if the first resonant frequency is smaller. For this reason, the recycled rubbers have better vibration damping properties compared to, for example, polyethylene. Here we can see the frequency dependencies of vibration transmittability of low density polyurethane foams. We can see that the first resonance frequencies are much smaller compared to high density materials. For this reason, these materials have better vibration damping properties compared to high density materials. Here we can see the effect of dimethyl sulfone concentration in rubber composites on damping properties. In general, if we have very high concentrations, the frequency, first resonance frequency is higher. For this reason, the concentration has a negative effect of vibration damping properties. Oppositely, it was found in the case of effect of the styrene concentration in rubber composites. You can see that with the increasing concentration of styrene, the first resonance frequency is decreasing. For this reason, the higher concentration of styrene has a positive effect on vibration damping of these rubber materials. Secondly, we've investigated the effect of sample thickness on vibration transmissibility. We can see that with the increasing sample thickness, the first resonance frequency is decreasing. For this reason, the material thickness has a positive effect on vibration damping. Similarly, it can be seen here in the case of polyurethane foams. Again, higher thickness has positive effect on vibration damping. And the last one was investigated the effect of inertial mass on vibration transmissibility for two different material samples. And it is evident that higher inertial mass has a positive effect on vibration damping. Higher inertial mass leads to decrease in the first resonance frequency. For this reason, it has a positive effect on vibration damping. So, shortly, the conclusions. We've studied the vibration damping properties of different polymer materials. It was found that better vibration damping properties were found for high density polyurethane foam materials. It was also found that the rubber composition has a big influence on vibration damping. It was found that the vibration damping properties increase with increasing the sample thickness, excitation frequency, and inertial mass. The vibration damping properties were compared based on the first resonance frequency. The advantage of this method is that this method is non-destructive. In order to compare mechanical stiffness of different materials, and furthermore, it's possible to apply some recycled polyurethane foams for vibration damping too. It has a positive effect for environmental protection. So, thank you for your attention.
Thank you, sir. Thank you for your presentation.
Morning, everyone. My name is Pranapa Gasimsili. I'm from Khon Kaen University, Thailand. Today, I will give a talk on the topic of sustainable active paper packaging based on vegetable waste containing green synthesis nanosilver. Okay, as we know, pulp and paper has consumed by many people over the years, around 600 million tons, mostly to prepare pulp and paper. We use the wood is a raw material, so this process might have a negative effect on the wood resource. Okay, another approach that we can use to produce the paper, we can use the cellulose from waste products such as fruit, vegetables, agricultural industry products to produce cellulose and pulp and paper. So it would be a variable resource to use the vegetable waste to produce the pulps and paper. Okay, in the process to prepare pulps and paper, we have the one process is a coating paper. The coating we use to improve mechanical property, hydrophobicity, and water vapor permeability. And at the present COVID-19 pandemics has generated a culture of new normal to avoid microorganism space. Therefore, to produce a packaging or paper with functional of antibacterial is very interesting right now. Coating paper with silver nanoparticle. Why we choose silver nanoparticle? Because silver nanoparticle are antimicrobial agent that has a good performance of toxic to microorganism, but it has a very toxicity to membrane cells. So if we use this kind of product, we're gonna save from it. Silver nanoparticle can be successfully synthesized by using a green process without using the toxic or hazardous chemical. So this process would be good for synthesis of silver nanoparticle. Therefore, objective of our research, this study aimed to develop paper packaging based on vegetable waste by mix with waste paper, and we're gonna study the different content of green synthesized silver nanoparticle for coating. In this case, we're gonna use starch as a binder for coating. Okay. And the last part of the objective is we're gonna study the property of the coating paper, such as antibacterial activity, water resistant, and mechanical properties. This slide shows the characterization that we use in this research. And the next, I will go to the experimental part. First of all, we have to collect the waste of the vegetable, and then we wash it, and then we extract the pulp from the vegetables. The next step, we're gonna prepare the paper by pour the solution of the pulps onto the mat, and then we're gonna make a sheet and then dry to get a paper. The last step for the preparation, we're gonna coating silver nanoparticle on the top of the paper. So in this case, we use cassava starch as a binder, and we also use the extracted solution from the waste vegetable to prepare the silver nanoparticle, because inside the solution gonna have a phenolic compound, so it will help the reaction during we convert silver ion to be a silver seal. Then next is our result and the characterization. This slide show the UV visible spectrum in the range of around 390 to 450 nanometer. This is these peaks represent to the formation of silver nanoparticle. From the result, we see that the highest peak will obtain from the reaction time about 80 minutes. So we can conclude that 80 minutes for synthesis of silver nanoparticle is the best condition. Okay, this slide we compare using only the starch and distilled water and using starch and mixed with the solution from the extracted vegetable waste. When we compare, we see that the red line, when we use the extracted from the vegetable waste, it can produce high amount of silver nanoparticle. So by reducing agent inside that extraction will help the reaction and produce a high yield of silver nanoparticle. Okay, this slide shows the green synthesis of silver nanoparticle at various concentration of silver nitrate. We use the silver nitrate from 0 millimolar to the 150 millimolar. Okay, the good condition, the best one we found at using of silver nitrate at 100 millimolar, or we call silver nitrate, we call silver nanoparticle 100 is our the best condition because it had a high peak that represent too high formation of silver nanoparticle and good dispersion of silver nanoparticle in the solution. Okay, next we're gonna test about the characteristic of the hydrophobicity. We found that after coating silver nanoparticle 100 provide the highest water contact angle. That means it had high phobicity on the surface. Okay, silver nanoparticle will create the roughness on the surface and improve the water resistance for the paper. And this is show the result of antibacterial activity and the tensile strength of the coated paper silver 100. After we coated the paper with silver 100, our product, our sample can be against 2 E. coli and Staph aureus, which is gram-negative and gram-positive bacteria. Furthermore, when you consider the tensile strength, you will find that after coating silver nanoparticles, tensile strength improve around 8%, and the tensile strength about 4.62 can be compared to other kind of packaging paper. In the conclusion, we can develop the packaging paper from the paper waste and vegetable pulps. We found the best condition for synthesis of silver nanoparticle with the reaction time of 90 minutes. The best concentration of silver nitrate for synthesis of silver nanoparticle is about 100 millimolar. In the coating with silver nanoparticle 100 millimolar provide the highest water contact angle and the highest hydrophobic on the surface. The coated paper can against the growth of the E. coli and Staph aureus, and also have a tensile strength in the length of the common packaging product. The coated paper with green synthesis will be a promising material for bioactive packaging application. Thank you very much for your attention.
Thank you, ma'am. Thank you for your presentation. It was very interesting.
Thank you very much.